Now it's time to know about some of the challenges that will face the NIDS, that will face the security administrator who will think of deploying the network intrusion detection system. One of the challenges is how to include deployment and access limitations to this network intrusion detection system. How would you face the shortage that you may face in the storage, in the processing of the machine running the network intrusion detection system, because it is not coping with all the size of the traffic it is receiving. Maybe the storage is not enough, the processing is not enough. So this would be a problem, and this would be uh, something that would limit the performance of this network intrusion detection system. How would you analyze the encrypted traffic? How would you cope with some traffic that needs to be decrypted before being analyzed and before generating alerts related to it? Encrypted traffic that is of unknown or that is of hard decrypting protocol leads to poor performance and slow performance for the network intrusion detection system. How would you deal with the quantity versus the quality of signatures? Would you generate an alert for certain quantity of signatures or for some quality of signatures that signifies an attack? Would you generate an alert for 10 signatures for a certain type of traffic, or would you generate an attack for a certain one that is signifying a problem, a serious problem for such type of attack? You can do so and you can do so. You can follow this way or follow that way. It's a point of design, it's a point of your choice. So that's why we are presenting here some concepts that you can use in your design in deploying and using this technology that is used, that is called network intrusion detection system. It is very costly for proper management. It needs someone who dedicates his time to analyze the traffic, analyze the alerts, take care of what it is generating, and know how to react and know how to uh, move and how to face the problems that are generated through the NIDS alerts. So we have deployment challenges, including also the access limitations. Sometimes over a switched network it is hard to to generate access or to grant access for the NIDS to all of the traffic, because the switch is separate collision domains. So you cannot sniff over the switch, and an NIDS device that is deployed over the switch cannot have access to all of the traffic. So where to put this NIDS to be accessible for all the traffic and to reach all the traffic, to be easy for it to analyze? The deployment of this NIDS need trained people, trained security specialists to be able to deploy this NIDS, to set up this NIDS, to configure the rules, to specify what are the type of alerts for each rule, to categorize the alerts, to detect the events of interest, to know when do we need this NIDS device to scream and to say there is a big problem, and when do we need this NIDS to just show a line on the screen saying that we have a problem or we have something that is wrong. So the deployment and access limitations are something that composes a challenge facing this NIDS. So there are a lot of challenges or a lot of things that needs to be thought of and needs to be determined if you are going to use the NIDS technology in your network. You should think either to use the deep inspection or the shallow inspection. The shallow inspection is fast but provides little fidelity because it examines only the header information of each packet and examines some limited payload data, maybe the first 65 bytes or something like this. So it is fast because the examination is for small portion of the packet, only the header, but the security is somehow of little fidelity because the attack may reside in the data, not the payload data, I mean not the header. The attack may be sneaky, may be away of this shallow inspection, and may reach your network after such inspection. So if you are interested about speed, then you should think of shallow inspection. But if you are interested about fidelity, you should think of deep inspection. Deep inspection is slow. It requires stateful tracking of data. It stores and buffers the data by group, 1 or 2 or 3 packets by group, and then inspects them as a group, all fields including variable length fields, which is hard to do, and then takes the decision either to generate an alert for all of them or to let them pass without an alert, to detect them as malicious traffic or detect them as normal traffic. So this deep inspection takes time and consumes resources, but it leads to higher fidelity in the security. It leads to more security posture. And of course, if you are going to use the deep inspection, be prepared with the resources regarding the processing, the storage, and the network connection, and the of course the security specialist that will be responsible for observing the alerts, taking action, and reading the log files related to this NIDS to be and to benefit from all the features of this NIDS that you have used or decided to deploy as deep inspection NIDS. Let's have a look at this diagram and see where can I place the NIDS. In this diagram, we can say the intrusion detection probe is set into 2 points. In the traffic coming from the internet reaching the firewall, the input of the firewall from the internet is detected through the intrusion detection probe, and the output of the firewall to the demilitarized zone is detected through the intrusion detection probe. It is as if this intrusion detection probe is measuring the performance of the firewall. Is it acting good? Is there a difference between the input to the firewall and the output of the firewall, or this firewall needs more configuration and more enhancement? So we are analyzing the performance of this firewall through the intrusion detection probes that are placed to its input and placed to its output, and seemingly comparing both of them. In the same diagram, we may have an intrusion detection system in the internal network that is sampling and taking samples and generating alerts to the internal network traffic, which may be more important for us. So this intrusion detection system at the bottom, which is trying to detect any attacks on the internal network and generate alerts over this internal network, may be more important to us than the intrusion detection system that is above, because the alerts on the one at the bottom signifies that your internal network, your precious network, your valuable data, your servers are under attack. So you may prioritize your intrusion detection systems one over another. You may prioritize alerts over another. You may set priorities to the events of interest generated from this one and generated from the other one. So these are all points of design that needs some experience and some artistic touches of the security specialists handling these NIDS devices. Thank you.